So there are other ways, besides what we looked at on Friday, to determine if it's a function. And there are definitely two different types of functions inside of that as well. So we need to talk about that a little bit. So first off, if this relation, if a relation can be represented by a set of points, and only a set of points, meaning you can't connect the points, then that relation is considered a discrete relation. If it only can be represented by a bunch of points, kind of like a scatter plot, and you guys have worked with scatter plots before, then it's considered a discrete relation. One of the ways that we can determine if something is discrete is whether or not the numbers in between the points have meaning. If the numbers in between the points don't have meaning or don't make any sense for that particular problem, then it's going to be discrete. Okay. If you can connect the points, using a line or a smooth curve, then we say that relation is continuous. Okay, so notice a couple of the key differences here between the top and the bottom. Okay, represented by a set of points, then it's discrete. Represented by a line or a smooth curve, continuous. Oftentimes, continuous is some type of measurement. So if there's meaning in between the 2 points, for example, weight. You can think about your own weight. Okay, if you're trying to lose, let's say you weigh 150 pounds and you're trying to lose 5 pounds, you can't magically just jump from 150 to 145, right? You have to go to 149.8 and then 149.7 and you keep going all the way down until you get to 145. All the measurements, all the numbers in between 150 and 145 have meaning. But if you were counting people in a class, like our class has 24 students, okay? If I wanted to find out, like today we have, today we have 2 people absent. So we have 22 students in class today, okay? Do all the numbers between 22 and 24 have meaning? Well, there's no such thing as 22 and a half students, right? We could have 23, we can have 24, we can have 22, but we can't have a decimal or fraction value in between. So that would be a situation where it would be discrete, because you're counting and the space in between the points doesn't make any sense. Now, one of the things that you're going to have to do in your homework is to determine if a relation is discrete or continuous. And you're going to have to do some graphing, and the way that you're going to tell is whether or not it makes sense to connect those points. Moving on. Another way to determine if something is a function, is something called the vertical line test. And you probably have some familiarity with this. And this is when we're looking at a graph. Okay. The key here is you use the vertical line test when you have a graph. So before, when we just had points, we would just look to see if x paired up with more than one y. And if it did, then it wasn't a function. If each x only went with one y, then it was a function. We can also look at a graph and determine if it's a function in the same way, except we use a vertical line to decide. Okay? So simply stated, here's what the vertical line test is. Okay? If you can draw a vertical line anywhere on the graph and it hits more than one point, then the graph is not a function. If it only ever hits one point, no matter where you draw a vertical line, if it only ever hits one point, then it is a function. And when you use the vertical line test, you're going to have to give me an explanation if it is a function. If it's not a function, then you can just draw a vertical line on the graph and show me that it hits more than one point. And we'll go through that in a second here. So I'm going to put a graph up here in a second. And all you need to do is sketch it. Okay, okay? Because I'm going to put 3 different graphs up eventually, and taking a picture of it, it's just going to take too long. You can do a nice little sketch of it pretty easily, okay? So here's the first one. Okay, so just draw a little sketch of that graph. Again, it doesn't have to be perfect, but draw just a little sketch of it in your notes. So here's the question you have to ask yourself when you're trying to determine if the graph is a function or not. Can you draw a vertical line? Which way? First off, which way is a vertical line?
Up and down.
Straight up and down. Perfectly straight up and down. Okay? Can you draw a line anywhere that will hit more than one of those points? The blue part is the graph, right? The black is just the axis. Can you draw a vertical line anywhere that will hit more than one of those points? So let me show you what this might look like, okay? There's a vertical line. Now I'm just going to grab it and move it, all right? Is it hitting more than one point?
No.
How about over here?
No.
Here, anywhere? Is it going to hit anywhere more than 1 point?
No.
No, it's never going to hit more than 1 point. And you couldn't draw all the vertical lines, right? Because there's an infinite number of vertical lines. This graph keeps going on and on forever. I could keep doing this and doing this and doing this. It's only going to hit one time. Okay? Now, so because of that there's an infinite number of vertical lines, to determine that it's a function, to explain that it's a function, drawing a vertical line is not going to work. So you have to have an explanation. And this is the explanation you need to learn. Okay? This is a function because no vertical line ever touches / hits, either one is fine, more than 1 point on the graph. So on a test or quiz, and in your homework, if you use the vertical line test to determine if something is a function, and you decide that it is a function, then this is what you need to write. No vertical line ever touches or hits more than 1 point on the graph. The vertical line test is just another way to show that x does or does not go with more than one y. Okay? It's just a graphic way to do it. Okay, so this one is a function. This is what you would write for your answer. It's a function, no vertical line ever hits more than 1 point on the graph. Okay? Let's look at the next one. Again, you can draw a little sketch. Does anybody still need this explanation up there? Am I going too fast? We're good? Okay. Here's the next one. Again, draw a little sketch of it. What do you think? Is a vertical line ever going to touch more than 1 point? Yeah? Okay, so you can just... Okay, so look. Is it ever going to hit more than 1 point? It gets close, right? When you get down in here and there's curves and stuff. But vertical line, it never hits more than 1 point. So that's the same explanation. Okay, it's a function. No vertical line ever touches, hits more than 1 point on the graph. So you would use the same explanation that we did for the first one for this one. Now, in your notes, you should just copy and paste it, right? You wrote it down once, copy, paste it. Obviously, if it's on paper on a test or quiz, you're going to have to write it again. Okay? Last example. Again, make a quick little sketch of it. No big deal. Is this a function? Will a vertical line ever hit more than 1 point?
Yeah.
Absolutely. It'll do it a bunch of times, actually. Okay? So let's look here. So when it's not a function, I want you to draw the line on there. You're going to write not a function. And then you're going to circle those 2 points. Okay? So when it's not a function, the explanation is a lot easier. You draw the line on there, and you show that it doesn't hit, that it hits more than 1 point. Now, it doesn't have to be that line. Okay? You could have chosen a different line if you wanted. All right? You could have chosen a line over here, which is fine, because there's a lot of different places where it hits more than 1 point. Okay? It only has to do it one time to not be a function, though, and here's why. Let's take a look. Let's zero in on these points for a second. So right here, the x value is about 2.5. Right, so the x is about 2.5, which means this point up here is 2.5 comma something. Looks like it's about 4.5. So I've got an x 2.5 going with 4.5. Then down here I've got x 2.5 that goes with negative 4.5. So 2.5 for x goes with this y and also with that y. So 2.5 gets paired up with more than one y. That's why the vertical line test works. It's still the same concept. X can only go with one y, but if it doesn't, if it goes with more than one y, just like on Friday, it's still not a function. The vertical line test is just a graphical way of showing that, okay? All right, so here's the type of problem that you're going to see in your homework. Go ahead and take a picture of that. So in this problem, you have lots of things going on, okay? We're combining some things that we talked about today. We're combining it with some things that we talked about on Friday. So we did this, determine if it's a function, one-to-one, onto, both, neither. That was Friday. Domain and range we talked about on Friday. Today we've talked about discrete or continuous, and we're going to talk about graphing now. And we can use the vertical line test if we want to. Now, there's a lot going on here. So I want to be careful and go kind of slow. First off, we have to graph. And here's the thing, okay? You have two choices right now to graph. You can either make a table of values. That always works. Every graph you ever encounter, if you have an equation, you can make a table of values, pick some x values, plug it in, and find the y values, and basically graph a bunch of points. You can always do that, okay? This part over here, this graph using linear equation strategies, I'm being kind of vague on that because this is something that I teach during Chapter 2, but it's also something you've learned before. You've learned the slope-intercept form and how to graph a y-intercept and use the slope to find another point. Okay, you've done that before, and I'm going to cover that again, but it should be review. So if you are comfortable doing that, because you know you're good at it, you're welcome to use it. I'm not going to prohibit you from using it, okay? If you've learned it in the past and you like it, you're welcome to do that. And in this particular case, this problem is in slope-intercept form, okay? So you could do that. However, what I'm going to show you is a table of values because, like I said, this is something that we're going to cover later in this chapter. All right. So notice here, I'm going to start like this. And I'm going to start with an XY table of values. And instead of going 0, 1, 2, I went 0, 2, 4. Does anybody have any idea why I did this? Anybody think they might know a reason why I did that? Why do you think I skipped 1 and 3?
Because they're odd numbers.
They are odd numbers. And that does have something to do with why I chose not to use them.
Easier to use.
Not always. What is x getting multiplied by in our equation?
3. Wait, no. X.
1/2. 1/2 x means 1/2 times x. So what that means is every time I take an x value and plug it in, it's going to get multiplied by 1/2. Okay? So if I were to take an odd number and plug it in here, and I multiply it by 1/2, it's always going to be a fraction. If I take even numbers and multiply it by 1/2, because what's the same as multiplying by 1/2? Dividing by 2. So if I take an even number and essentially divide it by 2, I'm going to get another integer. So in this first case, okay, I'm going to take 0 and plug it in. What's that equal?
Negative 3.
1/2 times 0 is 0, minus 3 is?
Negative 3.
-3. Okay, go ahead and finish the table. Okay. So, when I plug 2 in, that's going to be 2 divided by 2, which is 1. 1 minus 3 is -2. I plug 4 in, this becomes 2. Here's what your table should look like. Okay? Now I want you to graph it. Now hold on a sec before you do that. You have two options. You can either grab a grid from the internet and insert it into your work. You can turn the graph paper on Notability. Those are your two options. I don't want to see you free-handing a grid. I don't want it, I want it to be nice. So either grab a grid from the internet, a blank grid, or turn your graph paper on in Notability, and then make your axes and draw your points, label your points, and put that on a graph. So go ahead and do that now, please. Alright, so you notice here, I've got my points. Now before I decide whether or not to connect the points or not and make a line out of it, we have to decide if what's in between the points has meaning. Okay, so for example, I used x was 0 and x was 2. If I pick 1 for x, is there a point that goes with that? Could I plug 1 in up here and get a value for y? Sure I could. This is 1/2 times 1, which is a half. Half minus 3 is negative 2.5. So there would be a point. Would there be a point here? Like at 1.5? Could I plug 1.5 in and get a value for y? Sure. Okay, I can pick any x I want, and I'm going to get a value for y. So because the space in between the points has meaning and makes sense for this problem, we can connect the points. So you should get a straight line like this. Okay. Now, once we have this, we have lots of questions that we have to answer. First, so all we've done so far, the only thing we've done, all that was just to graph. We've done nothing else. Actually, we could answer one of the parts. Is this discrete or continuous? Right, we connected the points, it is continuous. We can answer that. It is definitely continuous. If it was just the points and we couldn't connect those points, it would be discrete. So we can answer that part. Alright, is this a function? Yeah, I mean, we just learned about vertical line test, right? Is there ever going to be a vertical line that touches more than one point? Nope, there is not. So it is a function. Okay. Now we got to find the domain and range. And once we find the domain and range, we can decide if it's one-to-one, onto, both, or neither. So let's talk about that for a minute. As I travel along this line, what are the x values that go with it? 0, 2, 4 are the ones I chose. Are there other x values that go with this line? 6. 8. Does 8 have a point? Sure. Does 10 have a point? Does 20 have a point? Does 50 have a point? Does 1,000,000 have a point on this line somewhere?
Yes.
Okay, how about in the negatives? Same idea. If I went way out here on x, would it touch the graph? Yeah, it would touch the graph. So the domain is every single number there is. How do we say that in math? All real numbers. I showed you how to make that script R. The domain is all real numbers. Do not write ARN. That's not a thing. That just looks like you spelled arm wrong. That is a script R. Haven't I showed you the script R yet? Yes, I absolutely have. That's good. Okay, so here's how you make a script R. So you put the one little line like that, and then you have a little curly that comes over it. Then you make an R. It's a script R. That means all real numbers. Okay? You can write the words out, all real numbers. You're welcome to do that. I did not have enough room to do that over here. Plus, it's more writing, and this is kind of a cool little thing. I don't know. All right, let's talk about the range. Okay? Let's think about the same thing, okay? Now we're talking about the y's. So here y is 2, could be 4, could be 6. If I went to 10, will it eventually touch the graph?
Yeah.
Sure. If I went to 100, would it eventually touch the graph?
Yeah.
Same with the negatives, okay? So this is also all the numbers, which is all real numbers, okay? So the domain is all real numbers, the range is all real numbers, okay? Can we ever use an x value more than once and get a different y? Okay, meaning, does the range, okay, because when we talk about one-to-one, onto, both, or neither, we're talking about the range. For example, here the y is -2. Can -2 ever go with another point besides this one?
No.
On this line? No, it can never. Can never be used more than once. Once it gets used, it's used. So that makes it 1 to 1. Does every value in the set of all real numbers get used on this line eventually?
Yeah.
Yes. So then it's also onto, which means if it's 1 to 1 and onto, that makes it
Both.
both. Okay? Now we've finished. We've done everything. We did the graph. We determined that it was a function. We determined it was both. We found the domain and range. And we decided it was continuous. Okay? There's a lot going on in that problem. Make sure you keep it straight. They're not all going to be this hard. Okay? But I wanted to show you a hard one so you knew what to do when you saw it. Okay? Questions?